Hi there. Let's do some problems calculating Ecell. So the most important thing to see, Ecell is actually E-red minus E-ox. Notice always the red cat. What is more positive, one become cathode, that is red cat, and it does the reduction. If it does the reduction, the secret agent, oxidizing agent, that's okay. So let's look at this question. So we need two beakers and two pieces of metal, two rods, stick it in, and then you add some electrolytes and just copy the equations from the data book, right? So, and yeah, salt bridge and the voltmeter, some electrolytes filled in, so it looks nice, so the diagram is complete, right? So now, when you look at the E cell values, you see the more positive one is the red cat. The positive sign, that's the cathode, then the other side is anode. Now notice anode has more electrons actually. That's why it pushed the electrons to the cathode side. And that's why the negative and positive signs as it is, right? Now we're going to plug in E cell is red minus ox. So the red we figured out minus 76, and then ox is minus 166. Minus times minus is positive, and plug and chug into a calculator, so you should get 90 volt, which is spontaneous, right? So two pieces, the cell diagram and the calculation. Now also remember, make sure that ox is the Leo. If it is doing oxidation, that's a reducing agent, and if it is doing GR, that's the oxidizing agent, right? The secret agent. So the two pieces, the picture and the calculation. Sometimes, depending on your class, your teacher might be going after the equation first, which is you find the balance equation. Zinc has 2 electrons and aluminum has 3 electrons, so you 3 by 2 get the least common factor and then add together left to the left, right to the right? Practice a couple of times this one and you get the balance equation. So now also remember this 6 electrons, 2 times 3 and 3 times 2, 6 electrons are given and taken. Electrons are not going to hang around, right? It's transfer through the conduction wire. Okay, notation. The cell notation is basically the direction of the electrons. So the aluminum electrons goes to the aluminum 3 plus and so on, right? So let's look at the other question. So this one also we're going to look at the 4 different things, the diagram first, then the calculation, then the balance equation, then the cell notation, right? A, B, C, D, 4 pronged. So in this case, especially, you are given magnesium nitrate and iron nitrate, iron 2 nitrate. So now also we know the two pieces of metal in the half cells. Now figure out this 2 plus from the electrolyte. It's not given, you're going to have to figure out. So magnesium 2 plus and Fe2 plus based on the formula given on the electrolytes. Now we copy the values from the data sheet. Magnesium has minus 2.37 and iron has minus 44. So they both are, you write always the standard reduction potential. Just copy it, right? Now look for the more positive value of the two. That's the red cat, positive sign. That's the GR. If it is the GR, it's the oxidizing agent, right? And then that's the cathode. So the electrons come to the cathode. The other side is anode, Leo, the oxidation, right? Now, E cell is red minus ox. We already find the red, which is 0.44, more positive one, and then minus 237, minus 2 minus positive, and then minus 0.44. You will end up with 1.93 positive. That's spontaneous reaction. So this calculation is better. You have proper brackets and plug and chug to the calculator, so you should be fine, right? So two pieces. Um, the diagram, of course, the moment you figure out GR, oxidizing agent, Leo, reducing agent, right? Now the balancing equation. So iron goes to iron 2 plus goes to iron, magnesium goes to magnesium 2 plus, 2 electron to 2 electron given and taken. You are good with that. And left to the left, right to the right, add together. Cell notation, direction of the electrons. Magnesium to magnesium 2 plus and iron 2 plus take the electron to iron. So anode to the cathode, that's the cell notation, direction of the electrons, right? Now, Again, we're going to go to the nickel cadmium one. So again, you can have two beakers, one beaker with the middle separation, but each case, just know the metal piece and the electrolytes in the beaker makes half cells, two half cells together. You get the voltmeter, and then that's a complete cell. And the salt bridge normally KNO3, right? And in this case, we put the nickel as nickel 2 plus, and nickel has a minus 0.23 voltage, and cadmium is cadmium 2 plus, and it has negative 0.40 voltage. Now we know more positive one is negative 0.23. That's the cathode, and the electrons come to that one. That's gaining electron is reduction, the red cat, positive sign. The other side is not, don't have to memorize, but we know it's the Leo, it's the anode, and oxidation, right? And if it is the case, then it should be Ra, reducing agent, right? Okay. Again, Ecell is red minus ox. You know the red is minus 0.23 and ox is minus 440, and minus to minus positive, and then add together you get 0.17 positive spontaneous voltage, right? So diagram and the calculation. Now the balance equation we can do. Oh, one more thing. It's better to spend some time to understand more electrons on the anode and little less electrons in the cathode rod. So that's why this flow. Now as a result, cathode gets bigger and bigger by depositing nickel on it, and the anode gets skinnier and skinnier by losing the cadmium into the solution as cadmium ions, right? So now that little bit of caveat there. Okay, so balance equation, nickel 2 plus to nickel, and cadmium goes to cadmium 2 plus and 2 electrons. Electrons conduction through, and then left to the left, right to the right, add together. That's it. Cell notation, direction of the electron again, cadmium to cadmium 2 plus conversion, and so on. Okay, the next one. So the cobalt and platinum electrode. This one has a little bit of a different caveat to know, understand. See, you have the cobalt rod dip in that side beaker, and then the platinum is expensive tiny little wire here. But hydrogen gas is actually pumped into this beaker, and it's hydrogen gas, it's a tank, but it's normally when it's released, it's 1 atmospheric, right? Now the cobalt reaction is cobalt 2 plus to the cobalt. Actually, it's a different one. We'll fix that. Now go back to the platinum. Platinum is an inert electrode. Platinum do not react, right? And so in this here, what the reaction is actually hydrogen going into H plus, right? And we can confirm that, yes, let's correct the cobalt. It should be 3 plus gets 1 electron and go into 2 plus. So that's 1.82. It's actually from a special battery, important one, but that's how it is. So 0 is more positive compared 1.82 is more positive compared to 0. So red minus ox, plug into the calculator, you get minus 0 is nothing. So that's how you get it. Now one more thing here. So losing electron is oxidation, and that's reducing agent is H2, and yes, gaining electron GER is cobalt 2 plus, right? Now we can balance the equation. Cobalt 3 plus goes to cobalt 2 plus 1 electron, and H2 goes to 2H plus, and 2 times for the cobalt to make it balance the electrons. Again, add left to the left, right to the right. Just see in case this one, see 2 times 3, 6 plus, and 2 plus, and 4 plus. So that's how you see whether you have it right. Okay, so cell notation again, H2 goes to H plus, and cobalt 3 plus goes to cobalt 2 plus, right? Okay, now a few other things. So these are straightforward just to write the balance equations. So zinc 2 plus goes to zinc, and copper 2 plus goes to copper, and then we can figure out which one, because zinc is negative, so we're going to flip that and add together, right? And likewise, look at the silver and zinc. Then more positive one is silver, keep the silver, flip the zinc, and add together, right? But never multiply the electrode potential value, right? Only the sign and the direction you flip. Thank you.